Okay? And you've got, and the notes for this, Dan, have gone to you already. So you will be able to catch up if you can't keep up with us here. So you already have those. So we have compounds responsible for temporary and permanent hardness, they're called. They have certain things in common, part of their elements, and they have certain things that are different, and you need to make the link between those. So this is a joke. It's a science teacher joke. So my kids laugh at this. They think it's hilarious because they're like, but it's true. I'm like, tut, tut, tut. So, do we know what hard water is? We live in Kilkenny.
It has limescale and stuff.
It does. Do you know what that does to, or limescale will come out of it? So you're seeing the hardness come out when you see the limescale. So anyone here not have a water softener? And you just go it and you have to replace your showers or your fridges. Is that you, Sam?
Well, in our old house, we rent out one house and it has a well, so there's no water softening.
So how much shampoo and shower gel did you go through?
Not much, because it's in Carlo, so the water is not that hard there.
Is it not that hard?
No.
Okay, so you're a terrible example for me. So hard water is water that's difficult to form a lather with soap. So if you actually live in an area that has hard water and you don't have a softener, you really notice it in your hair, because your hair is actually kind of feels really not good. You go through buckets of shower gel and washing machines and showers because they just can't cope. The hardness comes out of the water, and it is first and foremost due to the presence of magnesium and calcium ions in your water. So if you have hard water and you put soap into it, you get a scum that's on top. So it's an insoluble solid, and they call it scum, and it's due to the reaction with the stearate ions. You're actually taking the hardness out of the water when you add in soap. And in terms of how we express it, we express it as parts per million calcium carbonate. So you could have magnesium in there as your hardness, but they express it as calcium carbonate. Can you remember what parts per million mean? We had to do it before. Have we had to do it before? Yeah, we did a little bit in stoichiometry. No takers? So parts per million is the same as saying milligrams per litre. So in a titration, you'd have grams per litre and you'd have to do your conversion. So we have some good and bad things about hard water. Any ideas? Advantage, disadvantage?
It has more minerals and stuff in it.
Yeah, so why might that be good for us?
For your bones, calcium.
Yep, so it's going to definitely give you calcium for your bones and your teeth. They use it for brewing and tanning. Do you know what tanning is?
Leather?
It is for leather as opposed to looking gloriously coloured skin. So they use it for there, and some people like the taste. I actually really like hard water to drink. Disadvantages then.
It breaks washing machines and kettles and all that.
Yeah, so it's going to block your pipes. It'll leave scale on your kettles and inside your boiler. As I say, it wastes soap. So if you're trying to wash clothes, you're going to have to put buckets and buckets of detergent in there, and it produces the scum. I have all these papers in here. So can you remember when we made soap back in organic chemistry? Can you remember the name of the chemical name for soap? So we had our animal fat. It was base hydrolysis of an ester. And we cleaved.
Something steroid.
Correct.
Or is that just water?
Yeah, so it just depends on what kind of base you do your hydrolysis with. So when we did sodium hydroxide, it's sodium stearate is what we make. Is it okay to go forward?
Yeah.
Okay.
Yeah.
Sam, you okay? Yeah, Ruth? Alrighty, so soap is the sodium salt of stearic acid. So this is what it is. So if you get these structures, they use them more in university than we do in school chemistry. But except for here, every point along this is a carbon. And what they're not showing are the hydrogens that are attached. And the reason why chemists would use this is when you have giant structures. This is a much easier way to put everything in together. So you'd have carboxylic acids, you'd have alkenes, you'd have alkynes, you'd have double, triple bonds, all sorts in there, but this is just a simple representation of it. So we get the scum when the calcium and magnesium in your hard water reacts with your soap, and the scum itself is actually insoluble calcium stearate or magnesium stearate. And the reality is, once you add soap to your water, you're actually softening it, because you've gotten rid of your calcium or your magnesium. Okay, happy to move? Okay, Ruth is not.
Miss, do we take down that equation?
Yeah, just put it in. So all you're doing is you're just swapping the Na for the calcium. So remember, when we draw the salts of carboxylic acids, technically the part over here to the left is a negative and the sodium is a positive, so that's why here it's a 1:1. Here, because calcium is 2 plus, you have to have two negatives here to match this 2 plus, and this arrow here just means it's come out of solution. So we have two types of hardness. We have what's called temporary hardness and we have permanent hardness. So in terms of temporary hardness, literally boiling your kettle is enough. So if you have lime scale on the inside of your kettle, you do have hard water. This is really important to know. So it's caused by acidic rain, reacts with limestone, dissolves the limestone essentially, which then ends up in your groundwater and ends up in our home. So there are a couple of equations that you have to know to go with this. So does anyone know what the formula is for carbonic acid? You get it from the reaction of water and carbon dioxide. Any takers? It literally is, they all add it, there's no balancing. It's just rearranging to write a formula.
H2O plus CO2 gives CH2O2.
Not quite. So it's your water and your carbon dioxide and carbonic acid, be like sulfuric acid, H2CO3. So rainwater is naturally acidic. There's dissolved CO2 in rainwater, so carbonic acid is naturally there. And then just by us burning coal, burning fossil fuels, we add different things into the atmosphere that make rain more acidic than usual. So once you have your carbonic acid, it now reacts with limestone. Anyone have a formula for limestone? You have used it in your life and time in school. We use it as a base, a weak base.
CaCO3.
Correct. Okay, so we then have our calcium carbonate, so this is our limestone. And if you've ever been into any caves, all wee caves, there's done more caves out by Castle Comer. I was down in one in Kerry over the summer. The stalagmites and stalactites. So you're seeing the calcium hydrogen carbonate suddenly start to solidify, and that's making your stalagmites and stalactites. Now they have asked this question before where you have to write your equations for this. So I can remove by boiling my water, and when I do that I make the calcium carbonate again. So this is your lime, your scale in your kettle. So boiling literally takes your calcium and magnesium out of solution, and that softens your water. So if you can remember in your head in terms of the equations, the equation that has calcium hydrogen carbonate in it will always have calcium carbonate on the other side of the arrow. So calcium hydrogen carbonate is made from calcium carbonate, and when you decompose calcium hydrogen carbonate, you make calcium carbonate. Okay, so we're going to just move. So this is just showing you the inside of your boilers up here. All the white stuff is your calcium carbonate, and this then is the fur that you'd get inside pipes. So they're obviously hot water pipes, and all of the scale is just deposited in there. So eventually that's going to block and burst. So you have this little diagram in here. So it's just showing what we've done. Carbon dioxide and water forming the carbonic acid. Then your carbonic acid is going to react. We've gone with limestone, and you're going to make magnesium or calcium hydrogen carbonate. So it is acidic rainwater dissolving calcium and magnesium from your rocks. That is temporary hardness. So over the page there's a little table. We would have done this in school if we had it. So we would have taken our scale deposits, which no one has. So we would have taken a little bit of calcium carbonate, and we would have added it to hydrochloric acid, to methanoic acid, to vinegar, and to water. Do you want to have a little predict what you think it would do to lime water and what that result would tell you? So this is going back to reaction families. So what reaction family would this be?
Acid and base.
Yeah. Is it just an acid or base, or is it the acid and base bonus?
Bonus, because it's carbonate.
Because it's a carbonate. So I'm going to change my share to here. So see, this may play tinny.
Experiment of detecting carbon dioxide gas using clear lime water. Calcium hydroxide, which is known as clear lime water, is used to detect the presence of carbon dioxide gas produced from the reaction of sodium carbonate or sodium bicarbonate salts. With diluted hydrochloric acid, by passing the gas through clear lime water. What do you observe? Clear lime water turns milky on passing carbon dioxide gas through it for a short time due to the formation of springly soluble calcium carbonate in water.
Okay.
On passing carbon dioxide,
So this is we would have done the exact same thing. We would have put our calcium carbonate in a little test tube. We would have added the different reagent, and we would have put it into lime water to confirm whether or not this is something that's going to cause problems inside in your equipment. So if you want to make a little teeny tiny note of the little diagram, it literally is this easy. So you just have to have your tube going all the way in, and this is your calcium carbonate and your reagent, and this is your lime water. So when we do that experiment, it should have a positive result for hydrochloric acid, for methanoic acid, and for vinegar, because these are all acids. So these are all boys sing well bonus reactions, because you're making your salt, your water, and your carbon dioxide. Whereas this should have no reaction because there's nothing in there to react with it. Don't know why you are not working. Okay, so they will all go cloudy because you're getting carbon dioxide evolved.
Miss,
Yeah,
what is it that you have written next to the water in the little table?
is no reaction, because there's nothing there that can react with the base. So if you need to just remind yourself, these scale deposits, they are bases. So limestone is a base, calcium carbonate, sodium carbonate, they are bases. And they're bases according to Bronsted-Lowry, because they don't produce OH minus ions when you put them in water. So they don't follow the Arrhenius definition, but they follow Bronsted-Lowry. So they're Bronsted-Lowry bases. So we have 4 things to talk about in terms of permanent hardness. The fourth one is the higher level one. We have the video of the practical to look at. What is the sound like for you guys listening to YouTube through me? Is it good or bad, or you're happy?
Alright.
Is it okay? Is he
Yeah,
saying
it's grand.
okay, because I don't know, does it sound tinny? So look, what we'll do is, it's 35 now. We'll give a break until 45. We'll give you a good 10 minutes, because Chloe's breaking my heart. She needs to get outside for 10 minutes. Okay, and I'll still be here if you want to chat, but I'll give you 10 minutes, and then we'll finish our little 4 things. We'll watch our video, and we'll do the tiny bit of theory on that, and then we'll leave it. Okay, so 10 minutes, turn off your cameras. I'll mark your paper, Dan.
Wait, what do we do after the...
You come back
How
to
do we
me.
get back into the Zoom?
So all you do is turn off your camera and turn off your
Oh.
sound. And I will be here.